All right, folks, good morning or good afternoon, depending upon when you see this. All right, so we're going to our second day of chapter 1 today, and this is going to be a little bit heavy in the description and a couple of calculations. So we're going to do this. Make sure you follow along, answer the questions inside Edpuzzle, and do the homework. It's important you learn this, and it is going to be a little bit heavy today. So what we're going to goals for today is one, review the states of matter. We're going to introduce a fourth one, review changes of state, figure out how to calculate density or mass and volume that's related to density, look at the difference between mass and weight, review the metric system, and learn dimensional analysis. So you have 6 things we need to do today. And so let's go ahead and get right on it. So the state matters in chemistry. What do we mean by state? It's not Kansas, it's not Ohio. It's what we term how the matter looks at a certain temperature and pressure. So when we look at state, we're looking at as a function of pressure and temperature. And we're going to see that in our phase diagrams a little bit later. So, but first we're going to look at gas. Gas is defined as, and we've got liquid and we've got solid. So we're going at these 3 things. Gas is has no fixed shape or volume. Liquid has no fixed shape or indeterminate shape, but the volume does not change, is set, or is determinate. Solid shape and volume cannot change. So there are the 3 definitions of the gas, liquid, and solid. You should know this in middle school. Gas, again, no fixed shape or volume. You can compress gases and you can expand it. You can put it in any shape you want. Liquid, you can put it in any type of shape, but the volume is set. It's fixed. You can't change the volume. The solid, shape and volume cannot change. Whatever matter you have, if it's a solid, you can't really change the shape of it. And the volume you cannot change. All right, somebody's going to say, well, I can change the shape of my metal. Yeah, that's true, but overall, the shape, as a general definition, the solid shape and volume cannot change. There is a 4th one, and this is crucial because the way we're looking at phase is based on pressure and temperature. Plasma is not a phase, a state. Supercritical fluid is. And that is between a liquid and a gas. And it has to have a certain temperature and pressure to become a supercritical fluid. Plasma, by definition, is ionized gas. Let me see if I can do this better. Ionized. So, gas is part of the definition, so it cannot be a different state. It is part of a gas. So there are the 4 states: supercritical fluid, solid, liquid, and gas. Now we have changes of state. Here are the definitions of the changes of state. Sublimation and deposition go between a solid and a gas. So sublimation, you take that solid and it goes straight to the gas phase. And the deposition is when you go from gas to a solid. And we'll do some of this in chemistry. Boiling is liquid to a gas. Evaporation is similar but different. It's based on the kinetics, how fast it goes. Evaporation is a slow process. It is not considered boiling. So something we need to consider that, the changes of state is boiling and really not evaporation. Condensation, you get gas to a liquid. You see that every time you get out of the shower. Melting and freezing. Melting solid to a liquid, freezing liquid to a solid. These are the different types of changes in state. So what we have here is a phase diagram. As you go left to right, temperature increases. As you go from bottom to the top, pressure increases. And here's my solid phase. Here's my gas phase. Here's my liquid phase. And we got 2 points. Oh, up here is supercritical fluid. 4 phases. And this is a dotted line here. I'm going to make this solid for you guys. There is a definite phase change between these 2 regions. Now, the solid phase. Going from here to here, I'm going to call this 1. That's melting. We're going from a solid to a liquid. In reverse is 2. That's freezing. The amount of energy it takes to turn a solid into all liquid, you add that much energy to it, you take away the same amount of energy to go from liquid to solid. So the phase changes involve energy, and there's a distinct amount of energy per gram going from solid to liquid and liquid to solid. The difference is one's positive, one's negative. Gas phase. Now, I want to point out something. We either go like this when we're changing the temperature. We go, this is 3, this is 4. 3 is boiling. And 4 is condensation. They're opposite. Sometimes we can see it now like this, where this is 3 and this is 4. Doesn't matter which way we're going. What we're doing at this point, we're increasing the temperature. At this point, we're decreasing or increasing the pressure. So you can either do one or the other, go from liquid to a gas phase. Here, this is 5, this is 6. 5 is sublimation. And 6 is deposition. All right, either change the pressure or change the temperature, doesn't matter which way we're doing, but if you go from a solid to a gas, it's sublimation. You go from a gas to a solid, it's deposition. So 6 different type of phase changes that you need to know. Because I'm going to give you this slide without all the words on it. And it's up to you to fill it in correctly. That's going to be one of the test questions. Also, you notice we got triple point and critical point. Triple point, TP, not toilet paper, but triple point. All 3 phases coexist. And we're talking about solid, liquid, and gas. All occur at the triple point. At the critical point, the CP, that's where the supercritical fluid region starts. And SCF, supercritical fluid. I'll make that up here for you guys. SCF, supercritical fluid. And that is the critical point where that occurs. So if we increase the temperature, but the pressure is not the critical pressure, we still have a gas. Increase the pressure so it crosses this line, we're in supercritical fluid region. This occurs only in the lab, folks. It's not really available in nature, so most of the time chemists focus on these three regions: solid, liquid, and gas. So again, critical point and triple point. Triple point, all three phases. Coexist. And critical point above the critical pressure and temperature, supercritical fluid is present. All right, this is what I want you to learn. So we're going to talk about density. Density we have is defined as the amount of mass per volume. So its density is equal to mass over volume. It is an extensive property, or no, intensive property is independent of mass or the amount that we have. So the units are grams per volume per milliliter, and this is the units for density.